Today I'll be preparing a glass surface by etching it with HF, hydrofluoric acid. This is done in order so that I can prepare the surface for bonding with an epoxy. HF is a weak hydrohalic acid, but it's very good at etching glass, and it's also very good at bonding with bone, which is why I've got these safety precautions here. Alternatively, hydrobromic acid is a strong hydrohalic acid, but it doesn't etch glass at all. So I've got a 48% solution in water from Sigma Aldrich. It's around about $30 for 25 ml, which is just the right amount I need for my work. I don't want to buy any more than I need than is necessary, because it's nasty stuff and I don't want to store any of it for a prolonged period of time. This is the glass inner joint that I want to etch the top here, so that I can feed through some tubing at the top and then epoxy that in. And in order to do that, I need to surface treat the glass and etch some of it away so that the epoxy gets a very good bond to the rest of the glass. So this is the HF. This is what I'll be using. There are lots of safety layers, boxes within cylinders within. It's a Russian doll of safety measures here. So I was hoping that the glass inner joint would fit straight into the container, such that I wouldn't have to use a secondary container and transfer the hydrofluoric acid, but that doesn't seem to be the case. So what we've done is we found a smaller secondary container of the right diameter mouth, and all of these containers are made from high density polyethylene, which the hydrofluoric acid won't react with. So all of these containers are labeled appropriately, so that when people come into the lab, if I've got to leave this unattended, then people know exactly what's in here and what to avoid. So you can see that there's no visible reaction with the container there. So I'm just going to pour the rest of that in to provide a convenient bath for my glass inner joint. So we're going to put this within another container, such that it won't be spilled easily if one were to accidentally knock the container over. This is common practice with working with things like HF, and you'll notice that there's a plastic tray underneath it also to keep track of any spills. So that's the part there that I want to etch, so I'm going to feed the tubing through there later on, which I want to epoxy in. So here goes. We're going to add this joint into the HF. Unfortunately, unlike other chemistry videos on YouTube, this one doesn't have very interesting visual chemistry. There's no bubbling, unfortunately, although the action of the HF on the glass is a chemical reaction whereby the HF reacts with the quartz, the silicon dioxide in the glass, to form silicon fluoride, SiF4, which is a gas which can readily escape. But there's no bubbling here. I have no idea how long to leave this for. I've never done this reaction before. So tentatively I thought I might see if I see any visible signs of etching in the first instance, which we don't actually. It's rather disappointing, but sometimes life is like that. So we're just going to turn that around so that we get an even etch around the glassware. And I'm going to bring in a more appropriate secondary container, which isn't too tall for the other one to fit inside, also labelled with a HF etching solution. So in some of the chemical literature, especially in the Journal of Chemical Education, one can find a couple of articles on how to etch glass. And what's rather amusing is that some of these articles talk about using HF to etch glass in schools. Which is something which is unthinkable today. One could never etch glass with HF in any school. They're just far too dangerous, has a very strong affinity for bone. So if any HF comes into contact with your skin, then it will permeate your skin, attack the bone, and it may lead to nervous disruption also, as the calcium ion concentration is affected within the body. But these articles, they don't use the HF directly. They use a reaction between calcium fluoride, CaF2, and concentrated sulfuric acid. So there's a reaction between the concentrated sulfuric acid and the HF to produce, between sulfuric acid and the CaF2 to produce the hydrofluoric acid. One of the main reasons why you'd want to do this is possibly because you don't want to worry about storage of HF or transportation within a school, for example, and so you'd rather make it in situ than buy it. But here we're in a chemical laboratory where safety measures are adhered to, so we don't need to worry about that. This is currently being left for about 10 minutes, and also there's no etching here, not that we can see anyway. Although there probably is etching going on, but it's on perhaps on like a micro scale, so we can't currently see it. So just giving it a bit of an even coat there, because of course we want the epoxy to bond on the inside of this joint, and we want the epoxy to bond evenly. So yeah, after 90 minutes, the inner joint has been washed. This has been washed more than once, but the camera hasn't captured that. So this is probably okay to handle now, and all the waste has been disposed of in an acid waste container. So we're going to measure the thickness of this etch. This has been etched far too much for my liking, but we'll take this to the glass blower and see what he can do to it. So this is very thin. This is about, where are we, 0.71 millimeters. So that's less than 1 millimeter, but on the flip side, the other side of the joint, the thickness is, it's about 2 millimeters, 2.35 millimeters. So that's the finished product. And you can see the etch because the joint has been left on one side in the beaker, but we'll use this in the next video.